Hi, now today we are going to discuss about stack data structure. In the stack, actually stack is the linear data structure. Here we are going to discuss about the introduction of stack and operations and application. Now you can see the definition here. The items are stored in the same order as a stack order, last in first out or first in last out manner. The main principle of stack is last in first out, first in last out. So you can see this diagram, you can understand easily what is actually stack in the real world. So now you can see, so this is a stack of pebbles and this is a stack of roti, this is stack of coins. Now you can see all the pebbles are in the order in a stack manner. So if you want, similarly the rotis also now come, coins also. Now you can see, if you want to delete, if you want to remove any one of the coin in the middle, so you can't remove directly, right? You have to delete from the top of the stack first. Okay, if you remove this top, then only you can remove the remaining whatever you want to required one. So without removing the top one, you can't remove the required one. So that is the main principle of stack. So last inserted, the last means the recently inserted one gets removed first, and first in, the first inserted this coin gets removed last. That is the main principle of stack. So first in, last out, the first inserted coin in the element or anything from the stack that gets removed last. First in, last out, last in, first out. That is the main principle of the stack. Now coming to the operations. Now there are two operations. One is push, other one is pop. Push operation for inserting the elements, pop operation is for deleting the elements. Now you can observe this diagram. This is the stack. Push for inserting and pop is for deleting the elements. And there is a one pointer here, that is top. Top is always pointing to the top of the element in the stack. Let us assume there are 5 elements. The fifth element gets pointed by the top pointer. Okay, if there is no elements in the stack, the top will be -1, because the -1 is nothing is there in the stack. -1 means nothing is there in the stack. Generally, the memory location will start from 0, 0, 1, 2, 3 and 4. Okay, now these are the memory location. If the top is pointing to the memory location, that is actually the stack or top of the stack, means that is the last element in the stack. Now the, if it is top is -1, that is actually -1 means there is no elements in the stack. Now there are two operations, push and pop. Push operation is for inserting and pop operation is for deleting the elements. Now you understand. So these actually both push and pop operations will be done at the same end. Okay, both push and pop operations will be done at the same end, only one end. Okay, now let's go with this example. There are 5 elements that we need to insert one by one. The stack size is 5. Let us assume the stack size is 5. Okay, let us assume the stack size is 5. Now let us perform the push operation one by one. 24, first insert 24, push 24. So now, so as per the memory location, now this at 0th location 24 was inserted. Now the top of the stack also pointing to the 0th location. Now the top is actually, next we are going to insert the one more element. One is the 0th location 24 and 1th location is 56. Now top is actually pointing to the 56. Let us insert one more element into the stack, 4. That is third location, means memory location 0 to 2. Now top is actually pointing to the 4th in the stack. Now again insert one more element. Now the top is, the pointer top is here. Now again insert one more elements, top is here. Now likewise, how many elements that get still inserted according to the size of the stack. Okay, if the stack is 5, we can insert only 5 elements, then the stack will be full. Okay, now memory locations will be from 0 to 4. Similarly, let us consider we are going to perform the pop operation. Okay, pop operation may be like, let's consider the stack is full. Okay, before going to perform the pop operation, let's consider stack is empty or not, because if stack is empty, can we perform the pop operation? No. So that before going to perform the pop operation, let us find out whether the stack is empty or not. Okay, coming to the push operation, while inserting any elements into the stack, let us find out whether the stack is full or not. If the stack is full, can we perform the push operation? Push means insertion. If the stack is full, can we perform the push operation? No. So let us check, cross verify that condition, then we can insert the elements one by one. Now coming to the pop operation, before going to perform the pop operation, pop means deletion. So before going to perform the pop operation, let us find out whether the stack is empty or not. If it is empty, we can't perform the pop operation. Okay, that is the condition you need to cross verify, then you can delete one by one. Okay, if the stack is not empty, we can delete one by one. Okay, so now top is here, right? Now top is at element 2. So now top is here. Now delete one element and now the top will be decremented by 1. You can observe, while inserting, top will be incremented by 1, while deleting, top will be decremented by 1. Now that after deleting one more element, the top is here. Now after deleting one more element, the top is at the 1th location. Now the top is here. Now after deleting 24 also, now the stack is empty. So this is how the elements gets inserted and deleted. Insertion operation is nothing but push. Okay, and now the deletion operation is nothing but pop. Okay, now we understand. So this is how the elements gets inserted one by one. Okay, so now let's go with the, first of all, before going to the coding, let us understand what are the applications actually. So we can use a stacking function called stack, and how we are using in a function call. For example, the function in recursion, the function is calling by itself, right? The function is calling itself, that is called recursion. So how it is calling? According to the order of the stack. Now in the expression evaluation, postfix and prefix evaluation expressions also we can use the stack. Undo mechanism, undo, redo also we can use the, and text editors and browsers also we can use this stack. And balancing symbols, matching parentheses and brackets in C programming, opening braces and closing braces will be there, right? So once the braces is open, it must search for the closing braces. So that is also will be stored in a stack. And visuals also. So sure, examples like undo operations or checking the balanced parentheses and everything, where we can use the stack. Okay, this is the Python code that you can observe. The first we are going to create a class. Let us perform. We are going to write all these operations into the class. Okay. Now for this class we need an object, right? Now first of all this line gets executed first. Okay. STK is equivalent to stack. STK is an object for the class stack. Now when we are creating an object, directly the class, the particular object creation, the automatically the init constructor gets executed. While creating an object to the class, the init constructor get executed. Now you can see in the init constructor what is there here. There just a self dot stack is equal to empty, means empty stack was created. Empty stack was created while creating an object. Next, what is the next line? We are going to perform the push operation. Push 10. So now the directly the control will go to the push operation. Okay. When we are calling the push 10, the control will go to the push function. Okay. Def push self item. So what we are inserting? Item. Item means the element. Now there is a function directly method, that is append method. Self dot stack we have already created as an empty. Self dot stack dot append of item. Okay, the 10 item, the 10 will be going to store in item place. Now the 10 will be appended to the self dot stack. So self dot stack is an empty. Now the 10 was inserted into the stack. Similarly, we are going to call one more push function, 20. Now the control is directly go to the push. So now 20 gets will be 20 will be going to store in a self dot stack. Now the next element gets stored into the stack. Again we are going to call the push function with one more element. So control again going to the push. What we have written, simply self dot stack. There are dot append of item. That item gets inserted. Now let us find out the peak. Peak means the peak function, peak method returns the topmost element. So as per this order, what is the topmost element? 10, 20, 30. So obviously now according to this, you can see the first element 10. 10 gets stored here first. Next 20 gets stored here. Okay. Next 30 gets stored here. Okay, so now there are three elements. Okay, now peak returns the topmost element. Now the top is 30, right? Now the top is here. Now the peak returns the topmost element 30. Now stack dot pop, stk dot pop also returns. Pop means deletion. So how do you delete the element? Only the topmost element gets deleted. Now this is how the elements gets inserted, and the pop operation is actually just deleting the topmost element from the stack. Now 30 gets deleted. This is the output, sample output I have written here. So peak returns the topmost element, and this pop also the deleted element. Just we are printing the deleted element, that is 30. Okay, stack dot pop means the topmost element gets deleted, but here I'm going to print what is the deleted element. This is the simplest program to know how the this stack operations will be going on. Now the main important operations are push and pop, and peak returns the topmost element. Here we have written the logic. This function peak return self dot stack of -1 if self dot else none. The meaning of this line is self dot stack is it returns the topmost element. -1 means if it returns a -1 means there is no element, otherwise it returns the topmost element. Is empty, it return not self dot stack. Self dot stack is not there, means there is no elements, then it returns this is empty. Okay, these are the special functions we are added, and now this is the two functions are the most important, push and pop. Peak returns the topmost element if it is there, otherwise it returns -1. Okay, is empty returns when the stack self dot stack is something. Okay, now there are some advantages of stack. Efficient, actually, constant time operation, push and pop and pick, and it's simple to implement and use, and memory efficient, and uses only the memory required for the element in the pages of stack, fixed size actually. So in case of array implementation, the size of that particular will be fixed. The size of the stack will be fixed. And limited access. You can only access the top element, which might not be ideal in certain cases. So that is the one drawback. And one more one is compare stack with other data structures in terms of access time. So this is also the visualization of the stack also a little complicated than others. Okay, these are the some of the disadvantages. Now the final conclusion is stacks are powerful and simple data structures with wide range of applications. The final thought is the stacks lays the foundation of learning more advanced data structures like queues and trees. Now in the future, we can encourage the viewers to like, comment, and subscribe for more content on data structures. Bye bye.